They spend a lot of their day grooming each other. They're very concerned about who's who and who's doing what with whom and keeping up and catching up with everybody. And they've kind of capitalised on that, and they've become these kind of quite political animals, and they manoeuvre and use their social relationships to get ahead in the game and use that to enhance their position within a group so that they can get the best food, have the best allies, all those kinds of things.
All this networking had a profound effect on another part of the monkey's body.
Doing all that in your head, it requires a lot of computing power, you know, to keep track of who's what and who's who. It's like a big soap opera, and you need to keep on top of it all the time, otherwise you're going to suffer the consequences. So that pressure to always be on the ball, to always know what's going on within the group, selected for a better and more cognitive function, better brains in short.
The complex politics of group life seemed to drive an increase in brain size. It was the start of what was to become a distinctly human characteristic. Monkeys spread across the world, and it wasn't long before a new branch of brainy primates sprang up. Chimpanzees, gorillas, and orangutans are our closest living relatives. They are the apes.
This is Bo. He's an orangutan infant, and he's a member of the great ape family, which is the family that we belong to. So, like us, he's got grasping hands. He has a large brain for his body size, and because of that, they have long pregnancies and a very long period of parental care.
Trees have always been the ancestral home of the primates, but apes began the process of coming down to the ground.
The great apes are much bigger than monkeys. And because of that, they can't run along tops of branches in the way that monkeys do. They have to climb. They move along the ground, they climb up the trees, and they kind of semi-swing through the branches in order to get their food. Because of this, they've got a much more upright posture, and they've got a much broader chest than monkeys.
Apes tend to swing or clamber through the branches rather than leap like the monkeys, so they lost the need for a tail.
When they move around on the ground, the great apes have a particular unique posture. They knuckle walk. Like monkeys plant their hands on the ground, or sometimes just their fingertips, whereas the apes use their knuckles, or if the case of the orangutan, they they walk on their fists. And so that gives them a kind of much more semi-erect posture, and that's partly because their arms are so much longer than their legs. As they move around, they're just going to be much higher up at the front and the back because their arms are longer than their legs, and that's what they're resting on. Hello. Reminds me of my husband.
Apes may be close relatives, but we know they're not family. There must have been a point in evolution when our ancestors stepped out from among the apes and took a new path.
Hello, Danny.
To help identify the fundamental difference between apes and humans, Danny the chimpanzee is going to take Professor Leslie Aiello for a walk. First, they're covering their feet in mud to make footprints.
Yuck. Yucky. It's fun to play dirty, isn't it? Come on. Come on.
As they walk together, they leave a muddy trail behind them, which Professor Aiello can take a closer look at.
Well done. Let's see what we did here. The main difference in the print is in the chimpanzee print. It's short, it's wide, and you have the opposable thumb, or the big toe sticks out just like a grasping thumb in a hand. Now, if you compare that to a human footprint, our footprints are very long, relatively narrow, and again, very importantly, the big toes in line with the rest of the foot.
No other primate except humans normally walks on two legs. It is the most obvious feature that separates us from the rest of the apes. But was upright walking the key development that changed our ancestors' destiny? In 1972, one of the most exciting pieces of evidence regarding human evolution was discovered in Tanzania. It was not a fossil bone, but a track of footprints preserved in volcanic ash. They are thought to have been made by a remarkable creature that walked across this muddy ground over 3.5 million years ago.
This is a cast of the famous footprint trail from the side of Laetoli in northern Tanzania. And it's important because it's one of our earliest evidences of two-footed walking or bipedal walking in our early ancestors. Now, you can see the importance here if we compare the footprints. And this is one of my prints. And you can see here clearly that the big toe's in line with the other toes. And also I have a clear arch on the medial side of my foot. Now, what we can do is compare this with the chimpanzee footprint. And here you can see it's very different because the chimp has a space between the big toe and the lateral toes. Also, there's no evidence at all of knuckle prints. So whoever was making these prints was clearly walking on 2 feet. When we find evidence of upright walking, we have conclusive evidence that we have something that's on the human line rather than on the ape line. From what we know about the fossil record for human evolution, upright walking came first. It preceded the expansion of the brain, it preceded tool use. So when we find something like this, we can be virtually 100% sure that we're dealing with something that's a human ancestor and not an ape ancestor.
These footprints are tantalizing evidence of a remarkable creature. An ape that finally gave up its ancestral home in the trees and came to the ground.
This is so exciting because it's actual evidence of behavior. We don't have to infer from bones what the function was. We can just see it here. This is exactly like walking on a beach or seeing your footprints on the wet bathroom floor. We can tell what was happening. It's a snapshot in time. And you can just imagine them walking across this ash-covered plain, very much like we would walk today.
The identity of this creature was finally confirmed when they found a skeleton from that time, which seemed part ape and part human, called Australopithecus.
This is one of the best Australopithecine skulls we have. And if you actually saw this, it would have looked very chimpanzee-like. The brain's fairly small, just marginally larger than a chimpanzee. The Australopithecines had a fairly projecting face, but the nose was quite flat. It would have been a very ape-like or chimpanzee-like nose. One of the giveaways, though, that it wasn't a chimpanzee is that the foramen magnum, the hole through which the spinal cord enters the brain, is positioned underneath the skull. So the skull would have balanced on the spinal column. And this is a characteristic of a biped. So this individual, even though it superficially looked chimpanzee-like, would have walked on 2 legs and would have been on the human line.
The skeleton and footprints provided evidence for the Walking with Beasts animators to build Australopithecus. But with no creature alive today, it took a lot of advice from scientists before the animators could get one moving.
One of the things that I just don't think is going to work about this one is just simply the fact that it's so bent over. I mean, its legs are never straightening up. that if you imagine, well, yeah, exactly. If you try and walk like that,
Yeah, it's never going to do that in a
no, so
distance, is it?
you'll get 2 foot down the road. I mean, if you imagine it, if you were to stand up and actually stand like that for any period of time, it's such sort of hard work to get anywhere basically from doing this. It's by the time you get down here, I can already start to feel it in my thighs. You know, it's just I don't believe that's going to walk at all.
That's
a good posture.
Strangely natural, I think, isn't it?
Makes you look attractive.
The first one I started was this walk here. My initial impression was to go with a very chimp-like walk because it just felt like, let's try that first, shall we say. And then moved on to basically just bringing in more vertical, more upright. These are all fairly rough animations, just trying to get the idea for it. This is almost believable in that it's more upright and it's got the basic timings of a bipedal walk on it. But again, you're looking at there's an awful lot of movement going into getting these legs forward, which is again very, very inefficient. This was when we were, this stage was when I was trying the alternatives, shoulder and hip timings that the scientists had advised us on. Again, it's almost there, but it feels uncomfortable. There's a lot of effort going into each footstep. It looks like it's almost pulling its feet out of mud there, really. It's like it's got sticky feet, for example. And then from that one to what is the finalised one, which, although not doesn't look terribly chimpanzee or ape-like, and again also doesn't look perfectly human. So it's somewhere in between the two. But at the same time, it doesn't look like it's putting a great deal of effort into getting anywhere, which is the whole idea of a walk. I've learnt more doing this one cycle than I think of any other piece of animation I've done. You can actually see this thing almost developing, evolving on screen, which was quite interesting. And when you get to that point where it looks almost human, but then you suddenly think, no, actually, it's not quite human, is it? That's when we know it was just about right, because basically that's what Australopithecus seems to be. He's not quite ape, he's not quite human.
In one way, walking upright made Australopithecus physically closer to humans than to apes. But does that mean they started to behave the same way? With their hands free to use tools, had they changed into a creature which had started to take control over the animals around them?
Nice one.
South African scientist Dr. Bob Brain has made a meticulous study of the remains of the southern species of Australopithecus. At a cave called Swartkrans, he has found evidence to establish whether walking upright changed these ape men from harmless fruit eaters into casual killers.
This cave of Swartkrans is remarkably rich in fossil bones. Something like 240,000 fossils came out of this excavation alone.
Most were of animals that lived in the bush, but there was also a high proportion of ape-man's skulls, minus their bodies. To many, this was evidence of man's darker side.
But one possible explanation is that they had been cannibals and they had been professional decapitators, bringing back the skulls of their victims to the place where they lived, and that's how they ended up as fossils. But I wanted to look at the complete picture and see just what other explanations, what other options there might have been.
Dr. Brain had a hunch that the real explanation might be found by studying today's fauna in the bush.
Fortunately, many of the animals that one finds in the wild, in the bush today, are the same, basically, as they were 1 million, 2 million years ago. Some of them have disappeared. The saber-toothed cats have gone, but the leopard is still there, the lion is still there. Well, it seemed to me to be essential to go out into the bush and look at the places where kills had been made.
With an eye for clues, Dr. Brain found a classic kill site.